Hi, I'm Patrick Reagan. Welcome to the Networking Part 7 TCP/IP Suite video. In this video, we dig into the TCP/IP protocol suite that allows you to communicate with other systems and surf the internet. It includes discussions on Internet Protocol or IP, Transmission Control Protocol or TCP, and User Datagram Protocol or UDP. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the A+ exam. If you find this video helpful, don't forget to click the like button. And if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. TCP/IP Protocol Suite is the de facto protocol used with the internet and corporate networks. With the TCP/IP Protocol Suite, TCP/IP does not worry about how the host, computers, or other network connections connect to the network, which runs on the network access layer. Instead, TCP/IP was designed to operate over nearly any underlying local or wide area network, including Ethernet and 802.11 Wi-Fi. The lowest protocol within the TCP/IP suite is the Internet Protocol, or IP, which is primarily responsible for addressing and routing packets between hosts. A host is a computer or device that's running TCP/IP and is assigned a unique logical IP address such as 192.168.5.243 or 50.233.23.17 that acts as a digital home address. It is called a logical address because the IP address is assigned to a device on the network, but it's not tied to the physical hardware like a MAC address, and it can be changed or reassigned by software or network configuration. IP breaks down into packets and ensures that they're sent from the source to the destination. IP can break large packets into smaller fragments and reassemble them at the destination. IP also handles routing, which determines the best path for data to travel across interconnected networks, often via routers. IP is a connectionless protocol, which means that there is no established connection between the endpoints that are communicating. IP does not guarantee any deliveries. Packets get lost, delivered out of sequence, or delayed. Instead, it must rely on TCP to determine that the data arrived successfully at its destination and to retransmit the data if it did not. When we access resources, we like to use names because they're easier to remember. Name resolution is provided by DNS servers that translates from the logical names to the IP addresses or logical address. However, the underlying protocols communicate based on the hardware addresses based on the physical addresses called MAC addresses, which is assigned to a network interface such as your Ethernet interface or Wi-Fi network interface. The Address Resolution Protocol, or ARP, translates from the logical address to the physical address. RIP and OSPF are examples of two routing protocols that helps move packets between different networks. BGP is another routing protocol worth mentioning that is the primary routing protocol used on the internet. When a packet reaches a router, the router will determine the next step that gets to the packet closer to its destination and forwards the packet toward that direction. The Internet Group Management Protocol, or IGMP, is used for multicasting, which enables a group of network devices to share the same IP address and receive the same messages. Remember, multicast is a network communication method that a single source sends data to a group of receivers simultaneously using one set of packets. When communicating, you go through these following steps. DNS lookups is optional but typical. Your laptop asks a DNS server for the IP address of www.example.com and gets back an address of 93.184.216.34. Your computer prepares a packet where the source IP is 40.32.54.230, which is your laptop's IP, and the destination IP is 93.184.216.34, which is a web server. Before your laptop can send the packet to your home router, it must find the MAC address of the router, which is the default gateway or local address to the client's network. It sends an ARP request, who is 40.32.54.1. The router responds with the MAC address AABBCCCDDEFF. Your computer creates a layer 2 frame by wrapping an IP address in the Ethernet frame. Source MAC, your laptop, and the destination MAC router's MAC address. The frame is sent over the local area network. The router processes the packet by stripping the Ethernet frame, seeing the destination IP is outside the local network, and forwarding it toward the ISP using a new Ethernet frame with a new MAC address. The router will forward the packet to the next router that gets it to one step closer to its destination based on the IP address of 93.184.216.34. Routers across the internet use only the IP addresses to forward the packet closer to 93.184.216.34. Each time it reaches a router, it will ask, which way do I go? At each hop, the MAC address is changed, but the IP addresses stay the same. The server at 93.184.216.34 receives the packet. When the server responds, it will send back a response using its source IP address of 93.184.216.34 and the destination of 40.32.54.1. The returned packet travels back across the internet, eventually reaches your router, and uses ARP to find your laptop's MAC address where the packet is delivered. To summarize the use of addresses, Layer 3 has IP addresses or logical addresses, which are used for overall source and destination IP address and routing between networks. Layer 2 is the MAC or physical address, which is used for local delivery within a network. While the packets are basically delivered based on MAC addresses, besides the routing determining which way to go to forward the packet, it is the router that moves the packet from network to network. Essentially, the packet will enter one IP address and will exit an IP address. The Internet Control Message Protocol, or ICMP, is a crucial component of the Internet Protocol suite used for the network diagnostic, error reporting, and operational queries. ICMP is primarily used by network devices like routers and firewalls to send error messages and operational information to indicate issues with data transmission. When you use the ping and trace route commands, you're using ICMP packets to assess connectivity, latency, and routing information. The Transmission Control Protocol, or TCP, is a reliable, connection-oriented delivery service that breaks the data into manageable packets, wraps them with the information needed to route them to its destination, and then reassemble the pieces at the receiving end of the communication link. It establishes a virtual connection between the two hosts or computers so that they can send messages back and forth for a period of time. A virtual connection appears to be always connected, but in reality, it's made of many packets being sent back and forth independently. The most important information in the header includes the source and destination port numbers, a sequence number for the datagram, and a checksum. TCP uses acknowledgments to verify that the data is received by the other host. If the acknowledgment is not sent, the data is resent. You can think of the TCP protocol similar to United Parcel Services, where packages are tracked and must be signed when delivered. In addition, since the data packets can be delivered out of order, the TCP protocol must put the packets back in the correct order. TCP employs flow control and congestion control mechanisms to prevent the sender from overwhelming the receiver with data into a dynamically adjusted transmission rate based on network conditions such as packet loss and round-trip time. It uses a sliding window approach to dynamically adjust the amount of data transmitted based on the receiver's buffer capacity. The User Datagram Protocol, or UDP, does not use acknowledgments to ensure data delivery. The UDP header is relatively simple compared to TCP. The UDP is considered unreliable best effort delivery, and UDP does not use handshaking. Since it's considered unreliable, UDP is used for protocols that transmit small amounts of data at one time or for broadcasts where packets are sent to everyone. Note, unreliable doesn't mean that the packets will not get delivered. It's just that there is no guarantee or check to make sure they get to their destination. You can think of the UDP protocol as similar to the United States Postal Service, where it handles millions of mail items every day, which most by far get delivered, but there is not tracking of each item and no check to see if any item got delivered. UDP is suitable for applications that prioritize speed and efficiency over reliability. Remember, TCP is connection-oriented, which has a formal connection set up and close. It ensures reliable delivery because of the use of acknowledgements. It has overhead because of the use of acknowledgements, making it slower than UDP. Connection-oriented protocols include HTTPS and SSH. UDP is connectionless, and it has no error recovery, no reordering of data, and no flow control. It is quicker than TCP. Connectionless protocols include DHCP and trivial FTP. Every time a TCP/IP host communicates with another TCP/IP host, it will use the IP address and port number to identify the host and the service or program running on the host. This enables multiple services to run simultaneously on the same computer and to receive data intended just for them. A TCP/IP port number is a logical connection by client programs to specify a particular server program running on the computer on the network defined at the transport layer. The source port number identifies the network application or service that sent the data, and the destination port number identifies the application that receives the data. Port numbers are from 0 to 65,536. There are two types of ports, TCP and UDP, that are based on their respective protocols. Today, the very existence of ports and their numbers is typically transparent to the user of the network, as many ports are standardized. The Internet Assigned Numbers Authority, or INA, manages port numbers from 0 to 65,535. Well-known ports are port numbers from 0 to 1023 that are used by common services like HTTP using port 80, HTTPS using port 443, and DNS using port 53. Registered ports are ports in the range of 1024 to 49,151, are used by applications that are less common but need specific ports to work. These ports can be registered to prevent duplication. Examples of applications that use registered ports include Remote Desktop Protocol that uses port 3389, Xbox Live and Games for Windows, which uses port 3074, and IBM Lotus Notes or Domino, which uses 1352. Dynamic or ephemeral ports are ports in the range of 49,152 to 65,535, are assigned temporarily to applications when they need to establish a connection. These ports are not assigned, controlled, or registered. When you connect to a web server to open a web page, you send a request to port 80 and/or port 443. When it gets to the server, the port 80 and 443 indicate the web services running on the server. When the web server responds, it will assign a dynamic port to the requesting computer. Each requester will have its own port so it can keep track of multiple requesters. This allows the service or network application to communicate simultaneously with multiple clients. A socket is a virtual endpoint of a two-way communication link that acts as the communication channel between the two applications on different devices, allowing them to exchange data over a network. A logical address that combines an IP address and a port number to uniquely identify a specific application on host, enabling data transfer between applications on different computers. Sockets facilitate two-way communications between applications by establishing a connection through which data can be sent and received. Sockets can utilize different network protocols like TCP for reliable connection-oriented communications, or UDP, TCP port 53, and UDP port 53 assigned to the same IP address are two separate sockets. A web page is a hypertext document on the web that is delivered by a web server to a user using a web browser. The web pages are delivered via the Hypertext Transfer Protocol, or HTTP. HTTP and HTTPS creates connections via TCP. HTTP which uses port 80, has content sent in clear, non-encrypted text. HTTPS, which uses port 443, has content sent as encrypted content via secure socket layer or transport layer security. Initial encryption is done using keys stored in a digital certificate. Today, many websites will redirect HTTP connections to HTTPS. Domain Name System, or DNS, is used to resolve names to IP addresses. When you type in a URL in a browser and you try to connect to a server or computer, DNS will resolve the name of the server or computer to an IP address. DNS uses port 53. Early DNS used UDP, but more recent versions were upgraded with reliability, security, and privacy, which uses TCP. This slide shows some of the common protocols used in networking, including HTTP that runs over TCP port 80, HTTPS that runs over TCP port 443, and DNS over UDP and TCP port 53. To connect to a remote console to type commands, you would use the Telnet or SSH. Send files would use FTP, FTTPS, or SFTP. To receive emails, you may use POP3 or IMAP4 over TCP port 110 or 143. SMB offers Windows file shares over TCP port 445, and Lightweight Directory Access Protocol, including Active Directory over TCP, uses port 389. Question: what is the primary protocol suite used on the Internet? Answer: TCP/IP. Question: in the TCP/IP protocol suite, what is the reliable, connection-oriented delivery service that uses acknowledgments to verify packets are delivered? Answer: TCP. Question: which is faster, UDP or TCP? Answer: UDP. Question: when a TCP/IP host communicates with a server, how is the service or program identified on the server? Answer: by port number. Question: what does an IP address and a port number together define? Answer: a socket. Question: what do you call ports 0 through a 1023? Answer: well-known ports. Question: what ports are temporary ports? Answer: dynamic ports. Question: what port does the following network services use? Answer: HTTP uses port 80, HTTPS uses port 443, and DNS uses port 53. For more information, refer to these sites. In summary, TCP/IP protocol suite is the de facto protocol used with the internet and corporate networks. The lowest protocol within the TCP/IP suite is your Internet Protocol, or IP, which is primarily responsible for addressing and routing packets between hosts. The Transmission Control Protocol, or TCP, is a reliable, connection-oriented delivery service that uses acknowledgments to verify that the data is received by the other host. The User Datagram Protocol, or UDP, does not use acknowledgments to ensure data delivery. Every time a TCP/IP host communicates with another TCP/IP host, it will use the IP address and port number to identify the host and service or program running on the host. A socket is the IP address and its port number. Thank you for watching this video. The next video will be Networking Part 8, IP version 4 addressing. If you like this video, don't forget to click the like button, and if you have not already, subscribe to the Pat Has Your Back channel. Thank you.